Okay, so straight line graphs, and we're going to be finding the length of a line and the area bounded by lines. This exercise, so hit pause, make some notes. When you're ready, hit play again. Okay, so when we have two coordinates, x1, y1, like we have in the diagram here, and x2, y2, we can find the distance between them if we link them by using Pythagoras. So if we use Pythagoras to find the length of the line. Now, if we form our triangle like so, right angle triangle, we can see then that the distance between from here to here is going to be y2 minus y1. Whoops. y2 minus y1, and the distance here is going to be x2 minus x1. So if we use Pythagoras, if we call this distance we're trying to find d, we can say that d is going to be equal to the square root of this distance squared, so y2 minus y1 squared plus x2 minus x1 also squared. We complete that, and that gives us out the distance of the line. So make some notes, sketch the diagram, it's important, and when you're ready, hit pause. When you're ready, hit play again, and we'll look at an example. So in this example, we've got to find the distance between the coordinates 2, 3 and 5, 7. So we've got our formula, and it's written above there if you've forgotten already. D is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. So if we sub, it doesn't matter which way around you put them, but let's call this 1 and this 2. Then we've got the square root of y2, 7 minus y1, 3. So 7 minus 3 squared plus x2 minus x1, so 5 minus 2. It's also squared, so that's going to be the square root of 4 squared plus 3 squared, which I'm sure you recognize already. Square root of 16 plus 9, which is the square root of 25, and the square root of 25 is 5. So that's a 3, 4, 5 triangle. We haven't got any coordinates, so it's just units then. You don't have to write them. Okay, hit pause, copy the example down. When you're ready, hit play again, and we'll look at another example. Okay, for this example, we've got the straight line L1, and its equation is 4x minus y equals 0, and then another straight line L2, 2x plus 3y minus 21 equals 0, and they intersect at the point A. So find where they intersect, and then in part B, find the area of the triangle AOB. O is the origin and B is where the L2 meets the x-axis. So that's what the aim is going to be. I'm just going to do a quick sketch here of what these two lines look like where they meet. So you've got in at home, you've got your Desmos on your phone, on your tablet. Use it now and quickly sketch the line. If that's not very good straight lines, I'll have another go. Okay, so it's a bit better, not much. X and Y. The first one, 4x minus y equals 0. There's no y-intercept. That means it passes through the origin, and it's 4x, so it's quite steep. So I'm going to try and draw it through the origin there. Okay, that's L1. And the second one, then, I'm going to draw it in a different color. Let's go blue. The second one, 2x plus 3y minus 21 equals 0. So we've got a negative gradient there because it's going to be y is equal to minus 2 over 3. So it's going to come backwards on itself this way, like so. That's my L2 line. And the intercept is going to be 21 divided by 3. So it's going to cross it at 7 there. And that's the origin. It passes through the origin there. Okay, good. And that's my point A where they intersect. So it's just a quick sketch while I'm thinking about this question. Right. So I've got to find A in the first part of the question. In order to find A where they intersect, I've got first equation 4x minus y equals 0, equation 1, and then I've got 2x plus 3y minus 21 equals 0, equation 2. Now I could equate them. I could make this y equal the subject and then equate them, but I think easier than doing elimination is substitution. So if I rearrange equation 1 first, equation 1, so to rearrange equation 1, I've got 4x minus y equals 0, or 4x is equal to y, because I've taken that minus y over the other side. I can write that as y is equal to 4x. So I can now take this equation and sub for y in equation 2. So let's write that down. Sub for y in equation 2. Now equation 2 is 2x plus 3y minus 21 equals 0. So when I sub for y, I got 2x plus 3 times 4x minus 21 equals 0. So that means 2x plus 12x minus 21 equals 0. Or 14x minus 21 equals 0. Now if I take my 21 over the other side, I've got, I'll tell you what, let me just draw a line here, give me space to work. So I've got 14x is going to be equal to 21. So x is going to be 21 divided by 14. Now I can simplify that. I know 7 goes into both of them, so divide by 7. I've got 3 over 2. So x equals 3 over 2. So that's my x coordinate for A. And now I need to find the y coordinate, and I can sub this back into this equation here. Sub for x. So y is equal to 4x, which implies then that y is equal to 4 times 3 over 2. 2 goes into 4 2 times, so 2 times 3 is 6. So point A has coordinates of 3 over 2, 6. So that's our point A. We've done part A of the question. So what I want you to do now is hit pause, make some notes on this, and when you're ready, we're going to look at part B then. We're going to work out the area of the triangle AOB. Okay. Okay, so always useful to find, when I'm finding the area bounded by straight lines, to sketch the diagram. So we sketch the diagram out. We're missing a few coordinates here. 4x minus y has no y-intercept, so it passes the origin, nice and steep. And then I've got my 2x plus 3y minus 21 equals 0. Now I can put coordinates on it, because if I rearrange this in the first instance, I can find the intercept. Two ways I can find the intercept. So let's quickly rearrange it. 3y is going to be equal to minus 2x plus 21. So y is equal to minus 3 over 2, minus 2 over 3, sorry, x plus 21 divided by 3 is 7. So coordinates here are 0, 7. What about the coordinates here, which are more useful to me? More useful because I need to find this area here. Now I know this point here, that's A, which is 3 over 2, 6. So I've got those coordinates there. If I can find this coordinate here, how do I do that? Well, here, at this point, the y coordinate is 0. So if I say let y equal 0, so that implies then that we've got 2x plus 0 minus 21 equals 0. So 2x is going to be equal to 21 and x is going to be equal to 21 over 2. So the coordinates here are going to be 21 over 2 and 0. Now, area of a triangle, let's do this in a different color. It's getting crowded now with space. Area of a triangle is equal to base times height divided by 2. So I know my base, the length of my base along here from 0 to 21 over 2 is 21 over 2. So base is 21 over 2. And then the height is from here, this point, I draw a straight line as best I can down to there. So the height is going to be from 6 down to 0. So the height is 6. H is equal to 6. So the area is going to be equal to the base, 21 over 2 times 6, all divided by 2. Okay? Now, if we work on the numerator first, 2 goes here one time, 2 goes into 6 3 times. 3 times 21 is going to be 63. So 63 over 2 equals 63 over 2, which is 2 goes here 31.5 times. And that's going to be units squared. So that's our area. Job done. Units squared. So hit pause, make a sketch, make some notes, and I think it's your turn to do some questions for me. Okay, so you got, well, we got a total of 12 questions. Off you go. For number 1, you need to do some of these with negatives in them. So I'd say number 1, A, C, E would be a good one to do. And then after that, you're off. Plenty of questions to do. Don't forget, you've got plenty of hints here on the right hand side in pink. Okay, plenty of questions to do. You want to make sure you get stuck into the questions 11 and 12, but you need to work your way through it. Take your time. Questions like questions 6 and 9 are typical exam questions. They take you through step by step. Okay, good luck.